Hello, everyone. Good morning and welcome to today OpenShift TV session.
Hello, Fabian.
I will have the pleasure to have with me Andrea. Yeah. Good morning, Natale.
Hey, good morning, everyone. Welcome.
And our guest today will be Max. Good morning, Max. Would like to introduce you.
Good morning. Hi, I'm happy to be here. I'm Max Murakami. I'm working as a specialist solution architect at Red Hat, and thrilled to talk to you today about Red Hat OpenShift Data Science.
Okay, cool. Red Hat OpenShift data sciencing, or so do you mean we are talking to speak about the IML probably?
Yes, that's right. So, of course, OpenShift is a great platform for running all kinds of workloads, but what we're seeing these days more and more is organizations developing their own kind of data science and AI workloads. And with the OpenShift Data Science, we now have an offering to provide to data scientists, for example, such that they can run their own experiments and make use of the capabilities that OpenShift provides as a container platform.
Cool. And before getting more details today's session, I will invite you to have and share your coffee before smelling, and then cool, really cool.
Possibly
Natalia,
It's a tradition. Yeah, I had already.
Yeah.
Let me
have
finish.
your wonderful cup as always. Can you just ask you where did you buy your cup?
This comes from Shaka, from Sicily. This is a typical. You know very good because
I know very well. My question was not just
Shaka.
Great place. If you want to visit Shaka, we'll invite you to do it next summer. So, please, Max, before getting more details on OpenShift data science, I would like to ask you just a question: why we should speak today about OpenShift data science, Red Hat OpenShift data science? So, why Red Hat is entering in this domain?
Yeah, that's a great point. So, as you know, OpenShift is out there. Many people are using that for developing their applications. And it has a lot of great tools for doing the whole DevOps processing, for example, to really get the productivity of the developers out and make it really easy to kind of develop applications and put them into production in a fast and consistent way. So with the AI applications that we're now seeing, of course, much of that still belongs to the domain of classical application development, I would say. But what we're seeing more and more are data scientists producing what we call machine learning models, which become basically a new kind of business logic that are driving these kinds of intelligent applications. Think about image classification, which we're actually going to have a look at later, or in general, really trying to compress data that is coming in from various sources and try to really interpret this data and find out the kind of pieces of relevant data information to really enhance the business basically of the applications themselves. So, and with the OpenShift data science, it's one new offering that we at Red Hat are developing to really enable the more data science and machine learning specific parts of the whole development of machine learning and intelligent applications out there.
Okay, cool. There are lots of topics we can start to speak about, starting from what you already told us. And I don't know, Andrea and Natalia, if you have some question, otherwise we can probably leave the stage to Max with, I don't know if what you are going to present today, a demo, do you have any presentation? So up to you.
So I've brought with me two very quick demos, basically. So we can start off in a few minutes with having a look at what OpenShift data science looks like, how we can actually all use the developer sandbox out there together, and then maybe giving a bit of a broader picture, where does Red Hat OpenShift data science fit into the bigger picture, a little bit like what we just discussed. And then at the end, having a look at kind of deploying an intelligent application based on a machine learning model using OpenShift Data Science and OpenShift capabilities.
Good, I like that. Show first, give the demo, and then tell. So
that's
away, Max.
That's a great point, no? That's a great way to start the day, no? With a live demos, no cheating. Just show me the code, show me the demo.
Yeah, show us the demo. So, yeah, please, Max, I'll leave you the stage. Please share your screen. Okay. Okay, let's start, and then I hope you don't mind something. Anytime we will interrupt you, we'll do some questions. So, but please, over to you.
Okay, so I was thinking let's start in the developer portal. I think folks should really be familiar here, and maybe you've already realized. So if you have a look at the different products out there, that we're now seeing OpenShift Data Science. By the way, maybe I should make that a little bit larger. Okay.
Yes, please.
Cool. So what is that about? OpenShift Data Science. We can have a look at that, and we actually have a developer sandbox out there where people can have a quick look and already try out OpenShift Data Science. They don't really have to pay anything for that. All they need is a Red Hat account, which they can get for free. So let's just try to do this. So try OpenShift Data Science in the sandbox. And there's already quite some content.
Max, yes. Sorry for interrupting. That's a great point. So anyone who wants to start to play, to experiment, or just to get some more details about Red Hat OpenShift Data Science, it could be done just right now, creating an account and developer, a Red Hat developer portal, and you can create your own private environment with the sandbox technology, and please start to test and train your model. So please go ahead, Max.
Exactly. So there's a bunch of learning paths out there, documentation to really get familiar with using that, maybe also some kind of data science scenarios already. So what we're just trying to do is open the data science sandbox, and that's it, right? So we are in the console of the OpenShift Data Science. So you can see that there. Maybe again, make that a little bit bigger here. So there are different kind of applications in this OpenShift Data Science. So on the left-hand side, you're seeing 3 different tabs with enabled applications. So, and the Jupyter Hub is enabled by default. We'll have a closer look at that in a minute. Then you can check out all the applications that can be enabled by the administrator of OpenShift Data Science. And you will find some of the products out there, like OpenShift API management and streams for Apache Kafka. So those are the managed versions of our products, which really integrate nicely into the whole, intelligent application use case. And then there's a bunch of other components from third-party ISVs that we collaborate with, like IBM or Anaconda or Intel. And they are fully supported by the ISV and us. So they address also kind of different kinds of use cases over there. And then lastly, we have the ability to check out all kinds of resources, right? So we're talking about various documentations, tutorials, interactive walkthroughs about all of the components that I've just shown to you. So you can really have a closer look and maybe even have some kind of interactive quick start if you want to explore some of those. So,
okay, cool. So it comes to the first question. Mm-hmm. If I'm not wrong, this platform is a managed one. So it's running on OpenShift for sure, but it's a full managed one.
Exactly.
Am I wrong,
exactly.
Or? Okay.
Yeah. So
cool.
This is basically a software as a service offering right now, right? So in the initial stage right now, we're talking about a managed service on top of AWS. So if you want to, get this for yourself, basically as a customer or so, then you would take this as an add-on to either OpenShift Dedicated or Red Hat OpenShift on AWS, or short ROSA. Actually, I have to mention that this is still in field trial modus, so it's not fully GA'd yet, which also means that customers can just use this for free until it's in full GA.
Oh, cool. That's a
Yep.
great information.
So I see you are on the Jupyter Hub. My understanding is that Jupyter Hub is almost like the de facto standard tool that most data scientists use nowadays. And the question is, if a data scientist wants to get started with this, do they need to know OpenShift at all, or their knowledge of Jupyter Hub is enough for them to get started?
Yeah, so you're right. We're talking about Jupyter notebooks here, which are really, I would say, the vast majority of data scientists are really familiar already with how to use Jupyter notebooks, and that's where most of the data science work actually happens, basically. So I will give you a short insight into how this looks like. You know, I'm doing kind of work in the Jupyter notebook in a second. But even if you are not familiar with Jupyter Hub, then again, on the developer sandbox in the developer portal, there's plenty of content to kind of walk you through, how to use Jupyter Hub, how to use Jupyter notebooks. And the main idea here and what really makes this great in terms of the OpenShift data science and the Jupyter Hub that is provided as part of that is that I, as a data scientist, for example, don't need to worry about where to run my Jupyter notebooks, to provision the kind of workspaces around that, or maybe even how to get a good kind of base image for running my experiments. So those are actually quite important points, I would say. And
Max,
so,
can we say that this could be a Jupyter app as a service, kind of?
yes. Actually, that's a good description, right? So notebook as a service, Jupyter Hub as a service, basically just for you as a data scientist to really get quickly into the data scientist work without really having to worry, how do I actually kind of get there in the first place?
Gotcha. Thanks.
Thank you.
Okay.
We could say that Jupyter as a service could be a great use case to apply Red Hat OpenShift data science. So if a company want to implement for his data scientist and data engineer and want to provide a Jupyter as a service without lowering the effort regarding the ops part of managing everything, that could be a perfect use case.
Yes, exactly. So
Isn't it?
really taking advantage of the whole management of the whole platform in terms of OpenShift, in terms of the data science platform. So yeah, it's a really great way to quickly get into the data science work straight on.
Okay, cool.
Okay, so let's maybe now try to continue here. So let's say I'm a data scientist. I just want to get quick access to a Jupyter notebook where I can run some of my experiments. So I'm going to launch this application here. So and then we'll see a few options that I can choose from in terms of the to make that larger again, in terms of the basic notebook images. So those are the ones that are maintained by Red Hat and that offer some choice in terms of what kind of library stack I want to use in terms of TensorFlow or PyTorch, which many might be familiar with, but also like general various data science libraries, minimal Python even. So for our purpose, we're going to use the TensorFlow one. Then typically there's an option to choose like different sizes, if you will, of workspaces, depending on what the administrator wants me to use in terms of resources. So this will be enough. And I have the option to add any kind of environment variables to my workspace environments. So this is particularly useful if you want to inject credentials, right? Or endpoint information, like if you want to integrate Kafka or S3 storage, which I'm actually going to show you later in the second demo. So for now, let's just provision this, just starting the server and wait a couple of seconds until this has been provisioned for me. So again, I don't really have to worry about, about the infrastructure, the whole provisioning part, which in the older days might have taken actually hours or days until this is fully provisioned on top of a virtual machine. But here I have a containerized workspace just for myself, basically. Okay, so I'm graphical interface is loading, and here I am. So I have my own workspace for me. It's a blank workspace. I can either start writing a Jupyter notebook from scratch, but of course, as I said, I might already have some project with maybe some of my colleagues in a Git repository. So it definitely makes sense for me to check out and clone a Git repository that already contains some Jupyter notebooks that I might have worked on before. So I've prepared this one, and then it's cloning that. And yeah, I have this checked out. I can now go into this and have a Jupyter notebook that I've prepared before. So very simple one, and this is what it looks like. So for people who might not be so familiar with this, it's basically a way to interactively execute Python code and have a really nice formatted documentation alongside that, have the ability to run really pieces of or blocks of code in a very interactive fashion, right? So I would then start off importing my dependencies, building a very simple model out there, and then doing the actual experimentation work by training my very simple model out there, right? So I could just see in real time this is being executed. I'm seeing all the results in terms of the performance here.
Max, I'm sorry to interrupt you. Could you increase a little bit the font size?
Absolutely. I'm sorry if this is always a little bit too small.
Excellent, thank you.
Is that better?
Better.
Great. Okay. Yeah, and that's it. So as you've seen, I could really go like in 2 clicks, basically, as a data scientist, get here into my own workspace, and which already includes the dependencies in terms of the TensorFlow, and really quickly get continuing my work on data science work that I've done in terms of the Jupyter notebooks before.
Okay, so we could say that if we try to draw a sort of DevOps workflow related to the AI/ML development, this is the dev part. So you mentioned the GitOps part.
Mm-hmm.
So instead of anytime load the source code from somewhere, there is the source of truth. There's a Git, the Git part, and then there is one more thing that makes me think about standardization and governance in terms of libraries and release, which is a very important topic also for the AI/ML development. So because initially when you showed us how to create the developer notebook, which kind of framework you can involve. There is already the release. So it's a way to enforce also standardization about libraries that you can
Exactly.
instead of creating a sort of freedom also for frameworks to import. Is that something that probably can help also?
Absolutely. Yeah. And that's one of the very good points, I would say, why it definitely makes sense to talk about a centralized data science platform in the first place, right? So data scientists might be very comfortable and familiar with running their own environment on their own local machine, which is great to really get started quickly. But at some point, especially if you have a larger team and you collaborate on particular experiments and analysis, you might end up with kind of inconsistent versioning of the dependencies. So everyone has a little bit different kinds of versions of TensorFlow or maybe other packages. And at some point that might even lead to people not being able to reproduce each other's work. And you can imagine that, especially in the data science domain, this is super critical to really ensure that the model that you're producing is actually doing the right thing in the first place. So,
Right.
and maybe if you want to talk about the broader picture here, I've prepared a little bit of slides just to kind of showcase where all of this fits in. So what I like to talk about with customers or partners is this kind of AI journey as I see it. So of course, every organization has their own kind of unique use cases, but on an abstract level, I would say when it comes to technology, then what we're seeing is a kind of pattern and evolution, if you will, of typical use cases that have to be dealt with and considered. So I would say the very first stage is for an organization, before they have even tapped into AI, is the realization that they're owning a large amount of data, right? So everyone nowadays has some data in one form or another, and then the idea comes, well, we should really tap into this into this data to improve our decision making on the business side, right? So, and then you have a kind of discussion about technical challenges out there. So one major theme, I would say, without diving too deep into this, is taking care of a data infrastructure which enables you to tap all your different data sources out there, to integrate them such that your business analysts can get a kind of unified view on the business data. So based on that, I would say then comes kind of the second stage, where the organization is able to tap into the data, but they want to get even more kind of insights out of the data in terms of hidden statistical patterns, and when the first data scientists come into play. So data scientists really great at uncovering statistical patterns. And then we have another kind of technical challenges. And one of the major themes I would say here is really standardizing your approach to doing data science, and to have a look at a centralized data science platform, which makes sure that the data scientists are productive, have an easy way to provision workspaces, but also standardized in terms of the library stacks. And I would say then the third stage based on that is organization says, oh, great, we have now found some patterns in our data. Let's now try to develop some machine learning models such that my machines can automatically detect some kind of patterns in the data that we have, or maybe even data that is coming in. So to operationalize basically the whole machine learning thing, again, one challenge and one major theme is making sure that the machine learning training part, you can really optimize that in terms of automation, in terms of efficiency, and making sure that the data scientists and other folks are not spending too much time doing manual work here. And finally, just to make the picture complete, I would say the end state is where I would say this is the intelligent application, right? So we have the machine learning model then as a central piece of business logic, which is running inside of the intelligent application, and which is there to enrich and interpret the data which is coming in a real time. Could be either in terms of end users, think about classical web applications, or could even be about data coming in from edge locations, from sensors, from IoT devices, right? So we're seeing now growing numbers of those kinds of devices in various locations outside of the data center, which are producing massive amounts of data. So, and it really makes sense to process this data as close to the data sources as possible, to really extract the meaningful information from the business out of this data stream. So just to draw this picture of how you can go through as an organization through different steps and what kind of technical challenges are arising once you try to tackle the whole machine learning lifecycle, basically. So I would say there are two takeaways here, and from this kind of discussion. On the one hand side, what I want to show is that when we talk about AI projects, then we're talking actually, if you take a closer look at that, a vast range of different technical use cases which you should address, right? Starting with the data infrastructure, then doing the data science, the machine learning delivery, and finally the whole monitoring in production, the whole integration part. And the second thing is, where do we as Red Hat come into play? Well, we are great in terms of platforms. So, and I would say if you take a look at what actually happens here on an abstract level, so business logic is produced in some location, let's say, from someone who's developing that, and the business logic then has to somehow find its way into production and to be integrated in a larger system, which at a certain level actually resembles very much with what classical application development looks like. And we know that OpenShift, for example, is a great platform for doing all this application development to drive as reliably and as efficiently the business logic part from the development into production. And there's a lot that actually we can take now also for the domain of intelligent applications and machine learning to really tap into that and complement that basically with some capabilities that are more specific to the machine learning lifecycle here.
Yeah, you highlighted, Max, one of the aspects I think is one of the most neglected when we speak about AML projects, because the focus is always about the creating the model, which is requires a lot of effort, but then the path from the experimentation phase. So I created the model, okay, cool. My convolutional neural network for image recognition, great. Then I need to make it a real life application. I need to manage not only day 0, but also day 1, day 2, patching, modification, things that are the same for the traditional application development. So it's great that this platform comes to help and provides tools not only for the data scientist part, but also for managing the model in the production, during the production phase of the application, which is going to leverage that model.
Exactly. So, and you've talked about some of the use cases and some of the things that you really have to consider, right? And what we're actually seeing with organizations that are new to this domain of data science and machine learning is that they tend to focus very much on doing the data science part, developing the model, but then it becomes a really big challenge to kind of translate that into a productive system, right? Because actually you have a lot of other concerns that you have to tackle. How do you actually serve that model? How do we make sure that all of these processes are automated? How do you make sure that you can audit this, have a proper governance? How to monitor this in production? So, and those are kind of concerns which, again, at a certain level, remind us of concerns of application development, which are being tackled by what we would now call DevOps and GitOps, right? So we have a lot of established best practices in terms of application development. And we're now actually talking in the machine learning domain about MLOps, which is basically a translation of the established DevOps practices into the domain of machine learning applications. So again, without going too much into detail here, I've tried to sketch a kind of typical MLOps workflow, which, again, at a certain level reminds us a little bit of the application or DevOps workflow, I would say. So just making sure that the problem you want to tackle with this is defined. You know what the success criteria are. Then basically comes the whole development part of that project. Then comes the whole validation part, which is a little bit similar to software testing. And then basically the delivery into production integration into the larger system, and finally making sure that what is going on in production is also monitored as such. And just like the DevOps workflow, actually it turns out that also the MLOps workflow is very iterative in nature, right? So you don't really have only a straight line, but depending on the validation steps, you might have to kind of reiterate from certain other earlier points in your machine learning lifecycle. So, and all of this is really abstract. And if you now want to go talk a little bit more about the technology, then what I just want to show you on a very high level, again, without going into detail here, a kind of MLOps suite, if you will. So, because we've seen earlier, there are many different technical challenges that you have to address in your end-to-end machine learning lifecycle. So there's not going to be a single software that is going to address all of that. So we definitely have to take a look at different kinds of software technologies for different kind of use cases that arise, right? So talking about the data infrastructure on the one hand side, going to the whole, development and experimentation part in terms of the Jupyter Hub that we've seen before, and then again the continuous integration, continuous delivery, and finally the productive monitoring part. And folks out there who are familiar with OpenShift will immediately spot that some of the components are already part of OpenShift. terms of OpenShift pipelines, in terms of OpenShift GitOps for Argo CD, for example. So again, that's one kind of piece of evidence, I would say, that the classical DevOps tools, which we already have in terms of the DevOps process and what we can leverage in terms of making the DevOps really work efficiently based on those kinds of tools, are really nicely fitted to also a large part of what we're seeing in terms of machine learning development and machine learning deployment out there. And what we are then doing as Red Hat is basically having a vision like this, a suite, if you will, all based on open source tools, of course, and then try to gather this and collect and curate all of those different components that might be really worthwhile to have a look at for data science projects. So, and that's when we start talking about Open Data Hub. So Open Data Hub is an open source community project, which we as Red Hat are maintaining. And the goal is to collect all those open source tools, which we find, for example, many customers or partners are really enjoying using that, and to really consolidate and make sure that those are really nicely integrated, and from a technical perspective, are easily deployable on top of OpenShift, right? So we're talking about an OpenShift operator here, which is being developed as part of Open Data Hub, which makes it really easy for people out there to kind of compose their own machine learning suite, if you will, based on the particular requirements that they have, and just very easily deploy that, right? So we're talking about an operator which deploys other operators based on the components you have chosen, and then in the end you have a system which you can directly use on top of your own self-managed OpenShift cluster, basically.
Okay,
and
Max,
then we're
just
going,
a question.
Yes,
Sorry for interrupt you. So I'm seeing a big value here that you're showing. Probably, I would like to highlight is the OpenShift. OpenShift Data Hub is not just a collection of technologies regarding the IML domain, but not only ML, but it's an effort from Red Hat to provide end customers or partner an already ready to use, I could say, tools where all the components you mentioned are already tested, fully integrated, and provided to the end users as a whole. So instead of just mix and match or let people taking all these very variable frameworks around and trying to figure out which is the best release, which is the one that fits more for me. These are already fully integrated and tested for the end user. Is that something I think is of great value behind OpenShift Data Hub? As always, behind the fully open source solution provided by Red Hat.
Exactly. So think about Linux, right? So again, we have the same approach when we talk about what we're doing in the Linux space. Again, consolidating many different upstream community projects and consolidating and integrating and maintaining and curating that in terms of the Fedora project, right? So in this sense, you can say Open Data Hub is a little bit similar to Fedora, where then we as Red Hat, our engineers and quality engineers are then building finally a product out there, Red Hat Enterprise Linux, as a commercial offering to our enterprise customers. And that's actually a similar approach that we're taking here.
And we could say that without mentioning the end customers, we already have some companies using Open Data Hub in a sort of a production environment. So yes, to some extent it's similar to Fedora, but it could be used, though fully open source, also for enterprise grade projects.
Absolutely.
Is that correct?
Yeah. So we have basically a suite of open source tools, some of which are already massively used by data scientists out there in terms of TensorFlow, in terms of PyTorch, Jupyter Notebooks, but other tools which take care more of the integration and the delivery part. And yeah, definitely you can, if you have your own production environment, you can also deploy Open Data Hub and quickly get access to this kind of technology, right? So maybe there are, for certain use cases, a little bit, I would say, different support requirements when it comes to production support, right? So if you think about a development platform for data scientists, then this might have a little bit different criticality than if you talk about really production environment for real-time application delivery. So definitely you can take advantage of Open Data Hub to quickly get started, and yeah, make sure that you can use the different capabilities that are delivered as part of Open Data Hub for your own uses. And one of the other projects that we are heavily involved in is what we call Operate First. So this is basically a community which is operating Open Data Hub, actually, as well as other workloads. And the idea here is, again, the spirit of open source, that in a fully transparent and public space, there's a community that is actually operating that, and that is gaining operational insights and then sharing those operational insights for managing finally a productized service offering such as OpenShift Data Science, right? So especially now that we're seeing more and more complex software, the difficulty really becomes not only understanding what single entities in terms of code mean, but really how do you operate and integrate and set up all those different components and orchestrate that in an environment with a kind of production-like scenario, I would say. So this might be really interesting for some of you guys out there. So I will share a link also later on where you can also have a look at that. I see that we have already shared that. That's great.
Yeah, but
Okay.
anyway, let's share it again later. I think this Operate First topic would be well, a good point for, let's see, for next session about the AML. Okay, cool.
Yeah,
thank you.
And then only the last part, so we've already had a look at, is the Red Hat OpenShift Data Science, which again, where we're taking a subset of those community projects and really stabilizing and then again testing and verifying and hardening that to really make sure that we can offer that on a production grade support level. So we have that as a managed service right now. And just on a very high level to give you an idea what this is about, as I said before, managed service on top of AWS in terms of add-on to OpenShift Dedicated and ROSA for now. Of course, comes with kind of core components in terms of the Jupyter Hub that we saw earlier. Comes also with integration with other OpenShift services like managed services, or even, of course, services that are already part of OpenShift, as well as a number of ISV components, so a growing number at that, which address certain parts of the whole machine learning lifecycle, right? Again, talking about Intel, IBM, Anaconda, and more to come, definitely. So really giving also customers the opportunity to pick particular supported components for addressing specific use cases out there. Okay.
I have a question, Max.
Yes, please.
If I can. Do you think we can link I see the Red Hat OpenShift Data Science core is Jupyter Hub, PyTorch, TensorFlow, right? Mm-hmm. So how can we link, for instance, Kafka, OpenShift stream, managed Kafka to OpenShift Data Science, and then maybe we can link OpenShift Data Science to, I don't know, some Tecton pipeline somewhere, the MLOps. How do we link the MLOps sites to the OpenShift Data Science core?
Yeah. So actually, the integration with Kafka is something that I'm going to showcase in a minute.
Oh, cool.
So definitely makes sense, especially talking not about only the data science experimentation part, but if you talk about the whole machine learning lifecycle in terms of the intelligent application, definitely there's overlap with the concerns of typical applications out there when it comes to middleware, and that's where we can also see Apache Kafka come into play in terms of building an event-driven architecture, right? Or where we can see OpenShift API management coming into play, where it's really more about the governance of the public API that organizations may want to expose out there. So And the Tecton piece is interesting. So that's something which is currently available and being developed in the community as part of Kubeflow pipelines. We know that Tecton is, of course, also productized in terms of OpenShift pipelines. But there's a very interesting integration when it comes to really training and validating machine learning models, where we can also leverage Tecton. And this is actually something on the roadmap, which we will be able to deliver as part of OpenShift Data Science later, maybe this year even. And but this is actually something that you can already do in terms of Open Data Hub, right? So we have this integration already. We have Kubeflow, and there are great use cases for really automating the whole delivery thing, right? Without really, having to rely on manual processes or baking everything into a Git repository. So maybe really interesting thing to showcase at some point later on as well.
Thanks.
Yeah, sure.
Awesome.
All right, then I said that I have prepared this kind of demo here, which is basically based on the Rhodes Open Object Detection Workshop, which colleagues have prepared before. So maybe I can, no, let me go back. So guys out there can also just follow along and have some more details and documentation into the different steps out there. So the basic idea of the setting that I'm going to show you now is, I would say, a kind of hello world example in terms of computer vision, right? So we're talking about an object detection system which is running maybe even somewhere on premise, maybe in an edge location, let's say in a shop or a warehouse or a factory, somewhere where there's a camera, and we want to automatically track objects that are there and just to understand what's going on. So in terms of the architecture, of course, we have a camera sensor somewhere. We're feeding that in terms of event-driven architecture into a Kafka cluster, and the machine learning model, which is doing the actual object detection, is then being served and at some point also consuming Kafka topics, is detecting and classifying objects. And in the end, we have a graphical user interface where our user can see all the objects that are being tracked here. So, and the interesting part here in terms of the whole development thing is that we as a data scientist are working on the machine learning model, but maybe we don't want to do this in the on-premise environment, right? So we may take advantage of a public cloud managed service like OpenShift Data Science, for example, really have a centralized data science platform, and then we'll see that we can directly access kind of object storage in terms of Ceph storage here, and do our experiments, do our data exploration. And then the critical piece really becomes relying on Git here, right? So in this very simple example, we're actually going to use the same Git repository for the Jupyter notebooks, for the models that are being produced here, as well as the kind of glue code, if you will, for serving the model and doing the Kafka integration. So again, very simple example, just to see that it's very easy to get going with this, and to finally then rely on the source to image capabilities of OpenShift to basically convert the Git repository into a running container that is then directly being integrated into the intelligent application over here.
Yeah, thanks, Max, because this is a very simple example. At the same time, here you're drawing a very complex use case. Let's think about a typical edge use case where you have your enterprise data center, could be in the public cloud, obviously, and then you have your edge and the company's edge services or edge applications or edge services like image recognition. So you can develop and training your machine learning model in the enterprise data center, and then deploy everything in a standard way and using the same platform, which is always OpenShift. Also, it helps in terms of standardization, your application. So that's is that correct? Do you think? Because I'm seeing an edge application here in what you're showing. So simple,
Exactly.
but really complex if we think about real life application.
Exactly. So again, one of the great advantages of OpenShift really the possibility to run the same workload in various different modalities, right? Talking about various different public cloud scenarios, talking about on-premise, talking about really edge, and yeah, taking advantage of that fact for producing and developing one application in one particular location, but then having really the possibility to really deploy that in all the different kinds of modalities that really make sense for your particular use case, right? So of course, the data source is an important aspect here. Really makes sense to, on the one hand side, develop those machine learning models where the data is sitting on the one hand side, but also deploying then those machine learning models where the data is coming in. And oftentimes those are very different locations. And that's where we can also, again, leverage OpenShift in terms of this, hybrid cloud scenario where you're doing something maybe in the public cloud and then consuming that in an on-premise or even edge scenario, I would say. So yeah, cool. That's a very good point. All right, then maybe let's dive in. I have another OpenShift data science instance here, which we're going to run. So I'm trying to make this real quick because we don't have that much time left. So again, choosing a TensorFlow image here, and you already see that there's a number of environment variables, which because I'm going to integrate with Kafka and with S3 storage, and I'm then going to provision this Jupyter Notebook environment. So waiting a couple of seconds until that is provisioned, and the environment variables, of course, make sure that within my environment, I have access to Kafka, for example, with the endpoint, with the credentials, without having to provide those sensitive information as part of the Git repository, right? So that wouldn't make sense from a security point of view. So the server is now there. It's been provisioned. Now I'll automatically be redirected. Okay, and just as before, maybe making that a little bit larger, I'm going to now clone a Git repository, which already contains some notebooks that we're going to use. So I'm going to work now with 3 different Git repositories. So this is the main one in terms of understanding the model itself. We'll have a look at that in a minute, just because this is taking some time. Let me already switch to the other cluster. So this is the kind of on-premise cluster simulation that I have. It's a different OpenShift cluster, but anyway, something where we can already start deploying our application. So again, making sure to use the source to image builder just based on the Git repository. So that's the same one that I just cloned in the Jupyter Hub environment. It's detecting a Python service over there. And let's see that the names are correct over here. Okay, I want to create a route to that. So let's create that. So I'm doing this now because, as you know, it will now automatically clone that repository and start the whole source to image building of that container image. And then finally, the deployment of the service that is already defined in that Git repository. I will do actually the same with the other component, which is the front-end component. So here, we're talking about a Node.js application. Have to do a little bit more customization here to make sure that I can really call this. So, and finally need to insert a environment variable such that my front-end component knows where the backend component is sitting. So the one that is serving the object detection model.
Right, and you are using the service here, right? The Kubernetes service. So
Exactly.
The communication is internal. Cool.
Exactly. Yeah. So this is basically already the 2 components of my intelligent application, which will have a look once that is deployed. And I'm already also going to deploy then the last one, which is actually a Kafka client. So the one that is taking messages from the Kafka topic and then doing the actual classification on top of that. So if you will, that's a different version of that first component, which is not running as a REST HTTP server, but instead as a Kafka consumer. So that should be enough. We don't need a route here, and we can directly do this part. Okay, so while this is now being built and deployed, we can quickly check back here and check out our Jupyter environment. So I've cloned this repository. There's a number of Jupyter notebooks in there. And folks who are following along with the object detection workshop will see this more in detail. I will just have a look at one of the Jupyter notebooks, which gives you a clue of what the model really is, how it's being used. So again, doing the kind of interactive, stepping through those codes of blocks. First of all, of course, importing the dependencies, making sure that we download the data that is needed. So really dummy data here at this point from our Ceph S3 storage, basically. And then load the model that we have here. So this is the image that we have just downloaded from S3, and we want to apply object detection on this one. So ideally, we know we want to be able to detect 2 dogs on this one. So the model is already part of the Git repository, so we can directly load that straight away here, and then already do the object detection on this one. So this is taking a few seconds in terms of TensorFlow loading the saved model there. And now is actually the object detection. So we're talking about numerical values here. Let's see how we can get a nice visual representation of that. So some kind of helper functions that we have defined here. Let's display an image, and it's the same image with bounding boxes that the model has detected for certain objects. So there are small labels which are too small to read, but it says dog here, and also interestingly footwear for some of the paws. So we can finally do some filtering where the model says it's very certain that there's an object. And then finally it says that, okay, it's certain that it's detecting 1 dog in this area and 1 dog in the other area. So just as a kind of Hello World example, again, of computer vision application, just making sure that there's a model that can detect objects in a visual scene out there. So this is still running. In the meantime, what we can do. So here the approach taken is that we have one repository where I, as a data scientist, would do my work in terms of working on the Jupyter notebooks, expanding that, doing my experimentation, but also where the application developer on the other hand side can also work. So really joint collaboration within the very same notebook, and where the application developer would then set up the actual code, which is then being invoked in the service which is running in production, right? So in terms of prediction, how to actually call prediction of particular images, and how to actually formulate and define a web server. So here we're relying on a Flask server in terms of a Python server, and everything that is needed for the source to image to build a running container out of that is already provided in the very same repository. So this one really, again, very simple, contains everything that is needed from the data science perspective, as well as what the concerns are of the actual running intelligent application.
So we have our data scientists, which in a previous phase we didn't show today for sake of brevity, worked on training the model. Then we had our developers, data engineering developer, that worked in realizing the final application. And then thanks to the source of image, we are moving this real-life application into production. And I think it's worth to mention that everything could be automated. So all the manual step you did could be obviously automated through any kind of workflow.
Yes, exactly. So what I'm doing right now is adding the missing piece here in terms of the Kafka integration for the intelligent application. So what I've prepared beforehand was a secret which contains, the credentials and the endpoint of the Kafka topic, which I've set up before, and then making that accessible as environment variables to my components in terms of the front-end application as well as the back-end Kafka client. So here we're seeing that the REST service is already deployed, the front end is already deployed, so we can now start playing around with that. So if everything is set up correctly, then I should now be able to leverage. First of all, I have to stop my camera here so that the application can make use of that. So I want to be able to detect some kind of objects on some kind of visual scene. For example, this picture. What I'm going to do is now make this picture and see whether the model actually is able to classify that. And yeah, it makes sense that it has detected a car, maybe even multiple times, a wheel of a car, a person, clothing. It's not perfect, to be sure, but definitely something where we can already start playing around in terms of real object detection over here. So, and then the missing piece is available once the Kafka consumer is up and running. But already we already have some kind of hello world application which is able to detect objects in a visual scene based on some camera input and return that information to me. So I can then monitor what's going on, what's being detected, and maybe I can even use that downstream for some other application logic. So finally, the Kafka client is up. So let's try to see whether the final use case is working in terms of the Kafka integration. Now we should be able to track objects in real time. So it might take a few more seconds. Let's maybe restart that piece again. Yeah. So might be that we have to wait for another 1 or 2 minutes.
Yeah, maybe if there wasn't any liveness probe, readiness probe, the app is not really ready. No.
Yeah.
Could be.
Okay, but what we should see here?
Yeah. So again, as I told you, we're talking about an event-driven application, basically. So a stream of data is coming in from the data source, which is my camera in this particular case, and all the frames of the video sequence are then being passed to the object detection model, and the object detection is then being applied on those frames, and we should be able to see, just like for the different case, the different bounding boxes and the different labels of the objects that are being detected.
Okay, cool.
So maybe I won't get this done within the final remaining time, but this is the kind of use case that I wanted to showcase to you.
Okay. I think because we are running up to the hour, there is a question from Hamad Karim. Hamad, thanks for joining. Regarding the replacement of IBM Cabanero framework, because I don't think he's part of Open Data Hub anyway, or Red Hat OpenShift Data Science. Do you have any insight about this replacement? Just if you have it, if you're not.
Yeah, I'm sorry. I'm not too deep into IBM Cabanero. So this is nothing that we would provide in terms of Open Data Hub. Sorry, I really can't say much about this one particular.
Okay.
Yeah, it looks like if you go to the website, they say that the new development are based on Odoo and OpenShift GitOps. So probably it's something around, deploying and apps with Tecton and that kind of stuff. So yeah, definitely as Max was showing, Tekton, Argo CD, those are the tools also used for implement MLOps workflow. So, and you can connect to Red Hat OpenShift Data Science, and very cool, you can use also Kafka. Max, I was wondering if we can use also the managed Kafka here, if we can connect the ODS to managed Kafka.
Yes, absolutely. That's actually what I've set up in here, right? So
Okay.
due to time reasons, I couldn't really go into this, but you can definitely make use of the managed OpenShift streams for Apache Kafka. Again, you'll find the details inside of the workshop documents, and that's of course one of the great use cases for really getting this up and running without really worrying about the infrastructure piece.
Awesome. So it looks like we have at least two SaaS, no? One is Jupyter as a service, the other is Kafka as a service. And then Max, there was another cluster, if I understood correctly, a third cluster where you deploy the app.
Yeah, exactly. So based on this kind of schematic, so I showed you the data science cluster as part of the Red Hat OpenShift Data Science. And then I had provisioned earlier on another separate OpenShift cluster. So this is running also in the public cloud, but you can easily imagine that this might be running, on-premise somewhere, maybe in an edge location. And the same thing would work there, because once you have your workload running on OpenShift, then it can easily run on premises on OpenShift as well.
Awesome.
Yeah, if we just think about the OpenShift single node deployment, that could be one of the use cases probably.
Exactly. Yeah, and the very final thing that I wanted to say here. So if you folks want to get your hands on the technology itself, again, here are the URLs for the Road Sandbox with interactive learning parts that you can take, as well as the Operate First community. So please check this out, join the community, try it, Open Data Hub in a community context, and then it's more about really learning and exchanging ideas about data science, open source development, and SRE practices.
Thanks, Max. And Andrea, any question from your side? Or
Well, first of all, thank you for the excellent presentation. Demo effect during, but we really got the concept there, and it was very interesting actually to see all the pieces put together. In your case, obviously you had a demonstrator, so you're using an app to show to get the value from the camera. In an edge solution, there would have been some sensors somewhere else. Your app may have actually been running on OpenShift somewhere else, getting all the streams from Kafka and the decisions from the algorithms, and putting it all together in a visualization. That was actually excellent. It may be just a small example, but it shows all the components that you need. So my question would be, in a more complex situation, we have multiple algorithms, and they may not necessarily be deployed all in one go, in one single container. They may be considered as different microservices in a sort of a mesh. Is that a concept like that?
Yeah, exactly. So yeah, what we're seeing in real use cases, of course, massive amounts of data that are being processed, and of course there are certain ways to classify those kinds of objects or enrich those kinds of information, but on the same stream of data, maybe even for another business purpose, also identify other kinds of information within the same stream. So what we're seeing more and more is that not only single machine learning models get deployed, but really a number of those. Sometimes they might be running in parallel, more or less independently, but sometimes they might even kind of rely on the same information that a previous machine learning model has already identified. So of course you can try and do the integration yourself in terms of coding a large microservice like this, but there are already frameworks out there which can make that much more easy. So talking about model meshes, for example, so really frameworks that can enable you to define this kind of integration of different machine learning models in a declarative way based on Kubernetes resources, for example, right? So Selden might be one way where you can achieve this thing. really having a number of different machine learning models and then do the whole orchestration part as part of the declaration of the whole microservice, basically.
A model mesh. That's an interesting concept.
Yeah, cool topic.
Thank you.
So, Natalia, any question from your side? Otherwise, we are
out of curiosity, who owns this noisy chair? Like,
Oh,
no,
no.
it's not me.
That was a big
It's
me.
not me.
Okay.
It's not me. It's not me.
I thought you wouldn't pick it up because I had your microphone here. Oh,
I'm joking. You know, Max, I was impressed of the live demo where you showed the phone and you recognized the car, and you know, that is a real example of you know, real cameras doing AI face recognition. And this is all open source. I think, folks, we can share the links to all the demos. If you have, please, we can share in the chat, because this is really cool. You can try yourself the same demo that Max did and go into Sandbox, Red Hat OpenShift Data Science Sandbox, and try it out. So if we can share in the chat, that would be great. And Max, I'm impressed, and I would like to have you again here for another session, another demo, because
yes.
Super cool. Thanks.
and also, before we close, please don't forget our next episode of the series, Operators, next week on the 2nd of March, where we will learn how to write an operator, who is Java.
And Natalia,
Yes.
if I'm not wrong, there should be an OpenShift Commons session soon.
Today, Fabio, today at 6 p.m. our time, there is OpenShift Commons talking about how to use database as a service with the new roadmap that we started. We talked about it a little bit in our first database as a service series. And this is the other session. Maybe we can also link in the chat
Thanks, Natalia.
the event. If you can also please link all the repository of the demos, we can... and then
Yes, Max, if you have the link to the repository before closing, you can share it into the chat. And guys, thanks for joining. Thanks to all the attendees that have the pleasure to share their coffee today with us. We had the pleasure to have again Max, who showed us how create a simple, at the same time complex application in the ML topics to recognize image. And this started from the model, and he deployed everything in, let's say, production. Thanks again for the great presentation and demo. See you next for the Java operators session. Bye-bye.
Thank you. Thank you all
so much.
Bye. Have a good day.
Have a great day.